When we think about AI, we probably picture something that just exists in the cloud, right? Weightless. But the reality is, behind every single screen, it has this massive physical energy footprint. And we're going to dig into that. All right, let's just cut right to the chase. Here's the shocking part. The very technology we're all hoping will solve our biggest problems, well, it might be creating one of our biggest challenges yet. So, what's really driving that pretty scary warning? Well, it all comes down to data centers. The global electricity demand from these places is projected to more than double by 2030. Double! And just to give you a sense of what that number actually means, 945 terawatt hours, that's slightly more than the entire electricity consumption of Japan today. That's the kind of power surge we're talking about here. It's huge. Okay, so what is behind this just insatiable appetite for power? Turns out it's a combination of some really unique hardware and the absolutely relentless demand from AI systems themselves. First off, it really starts with the hardware. You see, the specialized chips that power these AI models, we're talking about GPUs, they eat up 2 to 4 times more energy than the traditional CPUs you'd find in a regular data center. And why is that? Well, a CPU kind of handles tasks one by one, right? But a GPU, it performs thousands of calculations all at the same time, which is perfect for AI, but wow, is it power hungry. It's literally like swapping out a regular car engine for a high-performance racing engine for every single thing you do. And here's the thing, this isn't just a one-and-done cost. Sure, training an AI model takes a ton of energy, but the real game changer is what's happening right now. As AI gets baked into everything we use, from chatbots to assistants, that energy cost becomes continuous. We're talking 24/7 for every single question you ask it. And this is where it gets really critical. This massive digital demand is slamming right into our physical power infrastructure. And let me tell you, that infrastructure is already stretched to its absolute breaking points. And that, right there, is the heart of the problem. We're trying to fuel a 21st century technological revolution using a power grid that is, in a lot of places, basically a 20th century relic. I mean, listen to this. The warnings coming out of the US Department of Energy they're pretty stark. We're actually retiring old power plants faster than we're building new ones. That puts the entire grid at risk of widespread outages. And if you're a new data center, you could be waiting up to 7 years just to get plugged in. 7 years. And get this, by 2030, data centers are on track to account for almost half of all the growth in electricity demand in the US. This AI boom alone is forcing the entire power sector back into a growth phase after years and years of pretty stable demand. So what happens next? Well, this new reality has kicked off what you could call a great power scramble. Companies, even entire countries, are now desperately hunting for reliable, powerful energy sources to fuel AI's nonstop growth. Okay, so where is all this power coming from today? Let's look at the US. A whopping 40% comes from natural gas and another 15% from coal. So yeah, that means a huge chunk of AI's current power diet is, you guessed it, fossil fuels. And this leads to a really tricky, unintended consequence. To meet this overwhelming, sudden demand, some places are actually being forced to delay the retirement of old, inefficient peaker plants. The very same plants we were trying to shut down to meet our climate goals. This urgent, desperate need for clean, reliable, around-the-clock power is leading the tech industry to a really powerful, and let's be honest, pretty controversial solution: nuclear energy. And a key technology at the center of this conversation is the small modular reactor, or SMR. The easiest way to think about them is like compact, next-generation nuclear plants. They can be built in a factory, assembled faster, and they're way more flexible, basically perfect for powering a massive, energy-hungry data center. So why all the buzz around SMRs? Well, for one, they promise constant, reliable baseload power. That's the kind of 24/7 energy that renewables, for all their benefits, can't always guarantee. They offer a way to tackle both energy security and our climate goals. And believe it or not, it's a solution that's actually getting rare bipartisan support. And look, this isn't just some far-off theory. Big tech is already putting serious money on the table. Amazon is backing an SMR developer called X Energy. Google has already signed power agreements with Kairos Power. They see advanced nuclear as a direct, practical solution to their massive energy problem. Okay, so all of this is building up to a really fascinating, kind of complex conclusion. Because for all its energy challenges, AI also presents us with this profound paradox. It's an old economic idea called Jevons paradox. And the theory basically goes like this. When technology makes us more efficient at using a resource, you'd think we'd use less of it, right? But what actually happens is we just find more ways to use that resource and our overall consumption goes up. Does that sound a little familiar? And that really is the ultimate dilemma here. On one hand, AI is this enormous new consumer of energy. But on the other hand, it's also an incredibly powerful tool for optimizing our energy systems, everything from designing smarter grids to making power plants run more efficiently. So it's both the problem and maybe a key part of the solution. And that leaves us with the final and most crucial question of all. The AI revolution is here to stay, and its hunger for energy is only going to get bigger. The real challenge for every single one of us is figuring out how to power this incredible future without wrecking the health of our planet in the process. If you want to stay ahead of the massive forces shaping our world, make sure you follow TrendPulse. We're more than what's trending.